Okay, thank you. So let's do the exercises you all have, I hope. And the idea is you just do them. And if you have problems, you raise your hand and put this up, post it on your computer. And we come and help you. And for those with Windows, I guess everything works. No, Gap should be working fine. Or somebody in Windows having problems? Yeah, okay, we will check it. And for those in Gap and Mac, there may be more problems. So depending on what installation you have, this should be the normal procedure. But if you have no compiler installed, you should also do this first.
For Linux, after having a Mac, you want to... For Linux, after the...
Okay, for Linux, it's also completely all the same. And if it doesn't work, then you get the GCC from your package manager. You have the package manager, you get the GCC from there. And Suganda, can you maybe help with the Windows sync? Okay. And the others do the exercises. I hope everybody has the exercise sheets. I will open it also here. And there's one typo in an exercise. The indices should be vertices. So this here are actually vertices. So I mean, it defines a graph, and the graph has vertices here. Okay, well, one important thing I forgot to tell, and which may be coming up frequently, if you do something, give a command to Gap which will not work, or give it in the wrong way, for example, I type symmetric group of 5,3, which makes no sense, then he will enter into a break loop. So I used it in the wrong way, and now I'm starting here with break and not with Gap. And if I do something wrong again, then he will enter into break loop 2 and so on. And to get out of this break loop stuff, you need to type quit, semicolon. And now I'm one break loop less. I'm now in break 1. Now again I do quit, semicolon. I get into the normal Gap. Just type it, don't type it too often, because otherwise you quit Gap also. Okay, so careful if you have a lot of data. Okay, maybe the last 15 minutes I will use to show you solutions of the exercises, and I believe everything I do here is recorded. I didn't know it before. And so you can later view it again and compare to your solutions and try to solve yourself the exercises. So let's start with the first exercise. So the exercise asks to find the number of subgroups, normal subgroups in the symmetric group of degree 4, in the general linear group of 2 times 2 matrices of a field with 5 elements. We can start by defining G to be the symmetric group and H to be the general linear group. And then there's a command which is also contained in the introduction list, which is all subgroups. So I can define subgroups G as G, all subgroups of G, and I can do the same for H. So it takes too long to print, I break it, but I can just, if I don't print the output, it works quicker, and now I ask the size of SG, 30, and the size of SH, 466. So this is the number, so I will comment it and it's recorded, 30 equals number of subgroups in S4, and 466 equals number of subgroups in GL25. And now the same for normal subgroups. So I define, for example, NG, normal subgroups of G, and I don't want to see them, so I don't put the output, and NH. And I can, again, just ask the size of NG and the size of NH. So 4 and 6 are the solutions you want. And for the conjugacy classes, so the next questions at this moment. Yeah. Hmm? Okay. So yeah, they didn't explain it. So this hashtag symbol, you mean this thing? Okay. So just up. And then you get, if I press up again, I get to the last command I was in. And if I press down, I go down again in the commands. You mean this, or no? Yeah, so it's just for comments. It's important, I forgot to explain it. So, I mean, it's not so important in the terminal when you're working, but when you're writing programs and you want to make comments, it's very important to do it, because otherwise you forget in half an hour what you wrote. You use a hashtag, and this gap ignores what is coming afterwards. So it's for comment purposes. And one more thing, Suganda mentioned, though, here we just work with basic functions, but often you have to load more functions, and there's a load package function for this. For example, tomorrow, I believe, or the day after, Vedarga will be a package we will use. You can load it like this. And then if it's installed properly, it will work. So let's come back to exercise 1. Okay, so now the number of conjugacy classes of order 3, 4, and 6 in G and H we need to find. So first of all, I define the conjugacy classes in G. Again, I don't want to see them, I just want to define them. And now I can just define, for example, I can list the conjugacy classes, and I send an element to a representative. But I don't want only the representatives, I want the order of the representative. So 1, 2, 2, 3, 4, these are the orders of the elements in conjugacy classes of G. So there's one class of order 3 elements, one class of order 4, no class of order 6. Of course, these are small lists, these are small examples, you can automate it, but here it's like manual, yeah. No, so in this way, when you do list, here you put the object you take from, and here you just put anything. You can also put G here, or I, or anything.
I'm asking about the back to X1. How do you go back to this X1, X1?
Just a comment. He just want to tell you that you
are back to exercise 1, I mean, because I was doing this other stuff before. This is just because it will be recorded, and then if you read it later, you understand better what is happening. So we have one conjugacy class of order 3 elements, etc. And we can do the same for H. And then, okay, it's more confusing. I think ordered list so it'll be working. Oh, okay, so we can define this, for example, to be L. And now we ask for positions in L of 3. This is often an important command, the positions, for any kind of list. Positions of 3, of 4, and of 6. Okay, so number of conjugacy classes of order 3 elements in H is 3, order 4 is 7, order 6 is 1. So this was the first exercise. Questions? Positions. So positions takes a list and an entry, and returns you all the positions inside this list where this entry is lying. So the third entry in L is a 4. So for example here, so he takes L, he looks for all the 3s in this list and returns to the positions it is. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. It's a 9 position, so this 9 is a 9 here. It's telling you where in this list this entry is, the 3. The 3 is only here, so it gives you the 9. The 4 is at the 3rd place, it's a 4. At the 7th place, it's a 4. In the 19th place, it's a 4, and so on. The 7 is very strange, no? What did I do wrong? Of order 3. Ah, it's okay, this is a typo here of me. It's true. Sorry. Great. Yeah. So the packages in Windows they're by default installed. And in Mac, what you have to do is go on the web page of GEP. So where we were before. And then there's this line. So on Mac, to install the packages, so enter GEP directory, then enter pkg. So just type cd pkg and then type this command. So bin two dots bin build packages.sh. You can do it in the evening or something. It will not build all the packages because there are many of them and some of them require additional software and so on. Don't worry, it will build some of them and hopefully it will build those you will need this week. And if not, we will help you. Okay, so maybe I can do one more exercise here so that you have an impression how it's done. Okay, so the second exercise is you want to write a program which is telling us the number of Zulu subgroups. So we're opening a text editor. In Mac, I noticed there's no standard text editor in Mac, I believe. But look on the internet for programming editors for Mac. Maybe Angel is using Sublime, you said, no? So for Mac users, Sublime, and for Windows users, there's a tip on the exercise sheet, actually. Like this? Maybe. Okay, so let's write this program. So you want to write a function, so number pseudo subgroups. It will be a function which takes G and P. So I want to highlight. And it will return the number of pseudo subgroups now. So what we need to do, so we can define S a pseudo subgroup of G at P. This is a standard function in GAP. And we can return, for example, the index of the normalizer of the pseudo subgroup. Now, for example, we can return size of G divided by size of normalizer of P in G. This is already a complete function. We declare the only local variable we have, S. Index should also be a command, probably in GAP. I don't remember it. But this one for sure works. Now it's only using very basic things. It should hopefully work. And this should be S, because I defined it as S. Okay, let's try it. Just copy it. And now I can try. So for example, number pseudo subgroups in G of 2, it's 3. Okay. You can check it by hand if it's correct. G is a symmetric group of degree 4 still, or in H, it's 15. Yeah. But all of this will be somewhere on the ICTS website, I think.
Yeah.
Okay. On YouTube even. Oh, okay.
On the notes on the
Okay. And yeah. Log 2. Yeah. Okay. One more point which came up is to save everything what you do, not to forget it later and to read it again. So on page 1 of the introduction, it's explained a bit, or in one line. So it's about log 2. So if you want to log things which you are doing, you can type log 2, ICTS.txt. And now I can again do things. So for example, the number of pseudo subgroups, I can ask for them again. Number of 5 subgroups. And if I open now the place I started my GAP from, which is my home folder, there should be a file called yes, here it is. It's ICTS.txt. So now this is a txt file which saved everything I did. And I want to stop this, I just do log2 empty. And then it stops logging. If I do now more stuff, it will not save it in this text file. Okay, it will save this one last line, it will save, and that's it. So maybe let's do exercise 3, or at least partly, to give you an impression how to work with a small group library. So the question is, how many abelian groups of order 64 are there? How many other groups of order 64 there are certain properties? So in GAP, we have a library of groups, at least for small orders, we have all of them, and we can just put them in a list. So these are now all groups of order 64. There are many of them, we can check how many. 277, yeah. And we can ask how many are abelian. So this is another important command for list, this is filtered. So you can take a list and you can filter it by a property. For example, it's abelian. And okay, this is a list, and I want the size of the list, so I ask for the size. And I get 11. So there are 11 abelian groups of order 64. Okay, and now he's also asking the same, but instead of is abelian, we're asking that G modulo the center is abelian. We can also write it in this one-line style. So we can send X to is abelian of X, but not of X, but of X modulo the center of X. So what is happening? It takes every group of order 64, which is from this list here, and checks if the group modulo the center is abelian. And it's 128 groups. Okay, and the other exercises are more elaborate, and I recommend you try. And all of us are here on campus. If you have questions how to do it, just ask us. Okay.
How to save the whole session before I get
You mean what I did now?
whole session?
So I could have saved it if I would have started with log 2, session ICTS number 2.txt, then I would have it all now, but
All from starting.
all from the beginning, yeah. But you saved it everything, no? So. Oh. I copy paste also works. I mean, okay, it's true. I can also now, I thought, I should have saved it before. I just do this. This, copy, paste, it also works. I mean, it doesn't work if you have a very long session, then you should log 2, but if you need to, you can use it.
The method which you told that you put that particular command log to at a certain point. After that point onward, it records.
Yes.
But if somebody forgets to put this command
In the beginning, then you have to copy paste.
there's no other way.
I guess there's a deep way you can go to your computer and it has somewhere in some temporary file, no? But I mean, if you think you should save it, then use log 2. Okay, thanks.